water inside a cup. Believe it or not, as I swing this board with a string, this water will not spill.
Mira lo que se avecina a la vuelta de la esquina, viene Diego rumbeando, con la luna en las pupilas y en su traje agua marina van restos de contrabando, y donde más no cabe un alma y se mete a darse caña poseído por el ritmo ragatanga, y el DJ que lo conoce toca el himno de las 12 para Diego, la canción más deseada, y la baila, y la goza, y la canta, y ahí se
Can you change the direction of an object moving in a circular path without changing its speed? Yes, you can. But what does it look like having a constant speed but in a different direction? This is what it looks like having a constant speed but changing direction. So velocity is a vector since it has a magnitude and a direction. Uniform circular motion is a motion in a circular path having constant radius and a constant speed. In a uniform circular motion, there is instantaneous velocity and it's always tangent to the circle. 2 by r is the distance of the object moves around the circle. Period is the time of the object to make one revolution in the circle.
Moving on, as Colleen said earlier, to have a uniform circular motion, an object must have a centripetal acceleration. And this is the derivation of the formula for the centripetal acceleration. So we have the change in velocity over velocity is equal to velocity multiplied the change in time over radius. And rearranging the formula, you will have the final formula for the centripetal acceleration, which is v squared over r. So what is centripetal acceleration? Centripetal acceleration is a form of acceleration an object is undergoing to when it is moving in a uniform circular motion. And it is denoted by a small letter a with a subscript of c. And the final formula is a sub c is equal to v squared over r. Velocity is also called the radial acceleration, and it is pointing towards the center. So, as you can see in this diagram, suppose this diagram is the water activity earlier at an instant. V sub 1 is the velocity of the object at time 0. V sub 2 is the velocity of the object at time 1. And the change in V is the change in velocity or the acceleration. Looking at the green arrows in the diagram, we would see that the arrow for the change in velocity or the change in V is pointing towards the center. And this shows that the direction of the acceleration is towards the center. So moving on, for an object to move in a uniform circular motion, there must be a net force acting on it. And according to Newton's first law of motion, an object will continue to move in a straight line or in a straight path unless acted upon by an unbalanced force. And this external force is what we call the centripetal force. And using the famous equation FMA, we could derive the formula for the centripetal force. We will just have to change the A in the FMA into the acceleration or the radial acceleration, and then we will have the equation for the centripetal force, which is the m multiplied to v squared over r. Centripetal force is not another type of force like tension, gravity, or normal force. It can be any of those. For example, the water activity earlier, the tension force on the string is also the centripetal force that causes the object to follow a circular path. So, in relation to centripetal force, you might have heard of centrifugal force. There is no such thing as centrifugal force or a force that is pointing outwards. What happens is that the natural tendency of an object to move in a straight line must be overcome, and that is the feeling that most people commonly mistake as the centrifugal force. When centripetal force vanishes, the object will fly off tangent to the circle as per Newton's first law of motion. As you can see on the picture above, the object is moving in a circular path, and when its string is suddenly cut off, it flies off tangentially to the circle. And as you can see also on the second picture, the sparks is also flying up in a straight line, which shows that the Newton's first law of motion.
Since you know what is uniform circular motion, let's jump into problems involving uniform circular motion. Problem number 1. A skater moves 15 meters per second in a circle of radius 30 meters. The ice exerts a central force of 450 newtons. What is the mass of the skater? So first, we need to illustrate the problem for us to better understand it. Next, we need to state all of the givens. First given is the centripetal force, which is 450 newtons. Next is the radius, which is 30 meters. Then the velocity, which is 15 meters per second. Then we need to state the equation for the centripetal force, which is mass times velocity squared all over radius. Then we need to derive the mass, which is centripetal force times radius all over velocity squared. Next, we need to substitute the values into the equation. Mass is equal to 450 newtons times 30 meters all over the square of 15 meters per second. Then, the final mass is 60 kilograms. The practice problem number 2. The wall exerts a 600 newton force on an 80 kilogram person moving at 4 meters per second on a circular platform. What is the radius of the circular path? First, we need to illustrate to better understand the problem. Next, we need to state all of the given. The centripetal force, which is 600 newtons. The mass, which is 80 kilograms, and the velocity, which is 4 meters per second. Then, we need to state the equation for the centripetal force, which is mass times velocity squared all over radius. Then, we need to derive the radius from the equation. Radius is equal to mass times velocity squared all over centripetal force. Then, we need to substitute the values into the equation. Radius is equal to 80 kilograms times the square of 4 meters per second all over 600 newtons. So, the radius of the circular platform is 2.13 meters. Next is the practice problem number 3. A 3 kilogram rock swings in a circle of radius 5 meters if its constant speed is 8 meters per second. What is the centripetal acceleration? First is we need to illustrate the problem to better understand it. Next, we need to state the given. Radius is equal to 5 meters, mass is equal to 3 kilograms, and velocity is equal to 8 meters per second. Next, we need to state the formula for the centripetal acceleration, which is velocity squared all over radius. Then substituting the values to the formula, we will have the centripetal acceleration, which is 12.8 meters per second squared.
Another type of circular motion is the non-uniform circular motion. So it's different from the uniform circular motion is that its speed may change and its acceleration is not constant, since it may accelerate or it may decelerate. The change in the velocity vector signifies the change in the magnitude of its velocity. The acceleration vector is parallel to the direction of the speed, then it is increasing. But if the acceleration vector and the velocity vector is at opposite direction, then it is decreasing. So another difference of non-uniform circular motion from uniform circular motion is that other than the radial acceleration, it also has tangential acceleration. So if an object is moving in a circular path but in varying speed, it must have tangential acceleration as well as the radial acceleration, as seen in the diagram above. Acceleration or centripetal acceleration is due to the change in the direction of the velocity. So, the formula of radial acceleration is given previously, which is the A sub r is equal to b squared over radius or r. As seen in the diagram above, the radial acceleration points towards the center of the circle. So, the next is the tangential acceleration. Tangential acceleration is due to the change in the magnitude of the velocity. So the formula for the tangential acceleration is the formula of acceleration used in kinematics, which is the change in velocity over the change in time. So the tangential acceleration, as seen in the diagram above, is tangent to the circle. To get the distance of one acceleration to another acceleration, you will need to use the distance formula, which is the square root of tangential acceleration squared plus radial acceleration squared, and it will equal to the resulting acceleration.
Solve problems using uniform circular motion. We will now jump off in solving problems using non-uniform circular motion. A 1,200 kilogram car accelerates from rest to a speed of 40 meters at a constant rate on a circular track of radius 800 meters. The first question is, what is the tangential acceleration? Letter B, what is the centripetal acceleration? And the last question is, what is the net acceleration? First, we will illustrate the problem so we can better visualize it, and then we will write all the givens. So the givens are 800 meter for the radius, the final velocity is 40 meter per second, and the initial velocity is 0 meter per second since the car starts at rest, and the time is 5 seconds. Using the formula for tangential acceleration, final velocity minus initial velocity all over time, we will substitute all the given to the formula, and then we will get 8 meter per second squared. For the second question, we will use the formula v squared over r to get the centripetal acceleration. We will use the velocity 40 meter per second over 800 meter for the radius, and we will get 2 meter per second squared. So for the third problem, we will use the formula the square root of tangential acceleration squared plus the centripetal acceleration squared. Since a while ago, we got 2 meter per second squared in the centripetal acceleration and 8 meter per second squared in the tangential acceleration, we will put those figures on the equation. And then we will get 8.25 meter per